This video is titled 3-7, 3-8, and it's all about the equations of parallel and perpendicular lines. You can write parallel and perpendicular, or you can use the symbols. And all of these video notes are brought to you by not so much the Hunger Games, but basically archery. So the angles created by arrows, I guess, being shot around. Okay, here's how you're going to set up your notes. So I would say you should leave about maybe 8 lines at the bottom. Let me go ahead and write that down. So why don't you save about 8 lines down here. And then this top portion is maybe about 10 lines. And then you have 2 glue-ins, and those 2 glue-ins are going to go by question 1 and question 2, and that should just be that middle section cut in half, okay? That's how you set up your notes. So I want to start off at the top of your paper with a key idea, and this is a key idea that I hope you remember. So go ahead and write this down. So parallel lines have slopes that are, and perpendicular lines have slopes that are. So the question is, if you have 2 lines that are parallel, what can I say about the slopes? And I have 2 lines that are perpendicular, what could I say about their slopes? I want you to take a look at this picture for a second. If I open this up and you really look at the parallel lines, so you've got a really good archer, the arrow should be parallel to the arm that's holding the bow, and you can see that really well here. So parallel lines basically should have the same slope. It means that they're rising and falling. So if I turn this like this, that means that this line is rising and falling, or excuse me, rising and running, and the line here is rising and running and rising and running, all at the same pace. So the idea is that if parallel lines have, if you see 2 parallel lines, then you know that the slopes are the same. So an example might be, one slope might be rising 1 and running 2, then a line that's parallel would also have a slope that is also 1/2. Okay? How about perpendicular lines? So perpendicular lines, so the example here is this guy right here. So perpendicular would mean that this arrow right here, a perfect shot would hit the bullseye, and when it would hit perpendicular to this line. Remember, perpendicular means it makes a right angle. So once this hits, then the angle right here would be 90 degrees, and that would be seen on both sides. So if I move my archer over here, they're almost moving at opposite slopes. So one thing I know for sure is that the slopes are opposite. That means if one is rising, the other should be falling. So that means one should be positive and the other should be negative. The other thing that goes along with positive and negative is that they need to be moving in opposite directions, almost doing opposite moves. And from that, we get actually the reciprocal. Let me show you what I mean. So if, for example, the slope was 2/3, then I know that if a line was perpendicular to that, first it would have to be negative because this first one is positive. But the second one, if the other one's rising 2, then this one should fall 3. And then if it's running 3, then it should run 2. So when I say that they're doing moving in opposite directions at different rates, this is what I'm looking for. So for this question, for question 1, it's asking, are these lines really parallel? They look like they're parallel, don't they? But are they really? When I ask, are these lines parallel, I could really rephrase this as saying, well, do these lines, do they have the same slope? Lines that are parallel have the same slope. So these are basically the same question. Are the lines parallel, or do they have the same slope? So we're going to have to take a closer look at these 2 lines. So I'm going to go ahead and write down some information about line 1. So line 1 is shown as going through 2 points, -6, 1, and 0, -2. And line 2 over here, line 2, is shown to go through the points 0, 3, and 4, 1. I'm going to go ahead and label these points x1, y1, x2, y2, x1, y1, and x2, y2. And the reason I'm doing that is because I remember that the slope of a line is the change in the y values over the change in the x values. So I'm going to use those this information to find the slope of both lines. So let's see what we get here. The slope of my first line, let's see, we've got y2 minus y1, x2 minus x1. When I do these calculations, I end up getting negative 3 over 6, which is the same as negative 1 over 2. That means the slope of my first line is going down 1 over 2, down 1 over 2, down 1 over 2. So to be totally certain, I guess I could check this one, do I go down 1 over 2? But without really doing that, I want to be very concrete, so I'm going to evaluate the slope of this line numerically using these 2 points. So let's go ahead and do that. So the slope of this line looks like this. So let's do y2 minus y1 over x2 minus x1. So when I do my calculation, I get negative 2 over 4, which when I simplify is negative 1 over 2. So let's go back to our original question. Are these lines really parallel? Do they have the same slope? My answer would be yes, they do have the same slope. They are parallel. I'm going to put a heart there. Okay. Now for our second question. Our second question asks, are these lines really perpendicular? Okay, so these lines look perpendicular, but do they really create 90-degree angles in all 4 of these locations? Well, let's evaluate the slope of both of these lines. Now remember, if I'm asking if these lines are really perpendicular, I'm going to be checking 2 things. Are the slopes opposite? And my second question is, are they reciprocals? So I'm going to have to show that both of these are correct in order to prove that it's truly perpendicular. And I can only check that by evaluating the slope of both of the lines. So let's check line 1. So line 1 goes through the points. Actually, I don't want to have an equal sign there. I don't know why I did that. Line 1 has the points negative 4, 4, and it also goes through the point 1, negative 1. And line 2 goes through the point 6, 3, and also goes through the point 1, negative 1. So these 2 lines both intersect at 1, negative 1. As a reminder, I'm going to go ahead and move my archery bullseye to the side. Here's my slope formula. Let's go ahead and see what happens when I find the slope of these 2 lines. Now remember, my first value is my x1 and my y1. My second point is my x2 and my y2. My first point is my x1 and my y1. And I have my x2 and my y2. Okay, so I like to set up my slopes. Before I use slope formula, I like to set them up like this. And then I plug in my values. That way I avoid kind of missing a negative here or there. Okay, so let's see. y2 is negative 1. y1 is 4. x2 is 1, x1 is negative 4, and when I do my negative 4, and when I do my calculations, I get negative 5 over 5, which is the same as negative 1 over 1. Okay, now for my next one. y2 is negative 1, y1 is 3, x2 is 1, x1 is 6. When I do my calculation, I get negative 4 over negative 5, which is 4 over 5. So let's check. Are my slopes opposite? Yes, one is positive and one is negative. Are my slopes reciprocals? Reciprocals. And the answer is no, they're not. That leads me to the conclusion that no, these are not perpendicular. So they are not perpendicular. Question mark, exclamation point, exclamation point. And why are they not? Because their slopes are not opposite reciprocals. So this last part of our notes is going to go at the very bottom of your notes in that last 8 lines. And the question that I'd like you to write is, are the lines given parallel, perpendicular or neither? Now we're going to do two examples down here, and I want to point out that I am going to do example 1 with you, and you are responsible for doing example 2 on your own. If example 2 is not complete, then you will not get credit for your notes today, so please make sure you do take care of example 2. So let's go back to the question. Are the lines parallel, perpendicular, or neither? Well, how are we supposed to tell? These lines aren't graphed. These both represent a line, but how do I know what they look like? How can I evaluate their slopes if I can't see them on a graph? Well, here's a hint. I would recommend looking at y equals mx plus b. If these equations are in slope-intercept form, then I can just see the slope. Well, here's the bad news. These two equations are not in slope-intercept form. They're in standard form. So if I'm going to take care of this problem, I'm going to need to take 3x plus 4y equals 12, and I'm going to have to get that y alone. So let's go ahead and do that. That'll be my first step. I'm going to take my first equation, and my goal is to get it in slope-intercept form so I can find the slope. So my first step would be to move the x term to the other side, because in y equals mx plus b, the slope has the x value on the right side. Now note that the negative 3x and the 12 aren't combined because they're not like terms. So they just come down as two separate terms, negative 3x and 12. My next step is to divide by 4, and I divide every single term by 4 to maintain the equality of the equation. I end up with y equals negative 3 over 4x plus 3. Now I can say that this line is in slope-intercept form, and I can draw the conclusion that the slope is negative 3 over 4. Okay, now what? Well, I'm going to need a little bit of space. I'm going to squeeze down a little bit. So I've taken care of this equation. Well, you know what's next. Now I have to look at 6x plus 2y equals 6. Let's put this in slope-intercept form. So again, I'm going to move my x term first, and I get 2y equals negative 6x plus 6. Next I divide all the way around, and I get y equals negative 3x plus 3. This is now in slope-intercept form, and I can see that the slope is negative 3 over 1. So let's evaluate this. Are the slopes parallel, or are they the same? No. Are they perpendicular? Are they opposite signs? No, they fail on that. One's negative and the other's negative. Remember, to be perpendicular, they have to be opposite reciprocals, one negative and one positive. And they have to be reciprocal, so this would be negative 3 over 4. This should be 4 over 3. Well, that doesn't work. That means there's only one choice. These two lines are neither. They're not parallel and they're not perpendicular. So now the question lies in your hands. Are these two lines parallel, perpendicular, or neither? Go ahead and take care of this last question before you move on to your next tier. Good luck.